Hello and welcome to another episode of Tutorial Thursdays. This week we're going to look at an important topic, which is pre-processing of your data. More specifically, we're going to look at spikes in your sensor data and how to remove them. I'm going to show you 3 different ways. Each way has their own distinct advantages and disadvantages, and they range from simple to a little bit more advanced. Now, before we dive in TrendMiner, a quick word on data pre-processing itself. One of the concerns when you're pre-processing your data is that you're actually changing the characteristics of your data. Think of averages, standard deviation, etc. But I think here it's important to remember that the data you're working with, the data stored in the historian, is already an approximation of reality. Flows, temperatures, pressures, those are analog continuous signals. Once they're stored in the historian, they no longer are. They are now discrete signals. Think of it the same way as music. When a band is playing live, the music sounds great. As soon as you start putting this raw music into digital format, you have to cut some corners. You have to work with different sample rates, you have to work with discretization, etc. And the final version, even if it's high fidelity, will be an approximation of that live band. The same applies here for your sensor data. We're no longer working with the exact raw data, we're now working with a digital representation of that data. So if you now add pre-processing steps, you're getting further and further away of the high fidelity of your sensor data. So you have to think about this when you're doing different applications. However, typically the error you'll introduce is insignificant to the application that you're using it for. For example, if you just want to calculate an average flow rate, average production rate, the error introduced will not be significant at all. Finally, there are typically reconciliation steps when you're matching final production to what's actually in your storage. So there are other ways to deal with it anyway. I think the most important thing here is consistency. If you apply certain pre-processing steps today, and I want to do this next month again and compare the 2 results, make sure you use the same pre-processing steps. I think that's the main takeaway when you're working with datasets. That being said, let's dive in and show you 3 ways in which you can remove spikes from your dataset. All right, we're looking at a simple flow, and what I want to do is calculate the average value over this 3-day period. As you notice, there's quite a few spikes in this dataset. That's because I introduced them artificially. I used a random number generator, and about on average 1 in 1,000 randomly distributed samples will show a spike, as you see on my screen. Now, I want to remove this, but again, the way I will do this depends a little bit on the application that I have for my data. In this case, I'm just interested in finding the average value. So the simplest way in this case would just be to leverage the search. In this case, the value-based search, in which I'm going to select that tag, and anything that is below 250, just kind of eyeballing it here, 250 is fine. Everything above that very clearly is a spike. So I will just add a condition 250 for 2 minutes and hit search, and I will find 41 different results. These are the time periods where my flow is consistently under 250. So I want to keep these, and I want to remove everything else. That is what this filter will do here. And you immediately notice all these gray lines that match perfectly with the spikes I had in my dataset. By far, this is the simplest method. These gray periods are now no longer active. So if I go into my compare table, I will find the average value around 185. This is disregarding all the filtered out data. Advantages of this way of working: very, very simple, very, very quick. Disadvantage is that it's a little less flexible. If I now want to look at other tags, these filters remain active. So that might be something I want to avoid. That's why we're going to look at the second way, which is clamping the data. Clamping the data means that I'm going to add an artificial high limit on my dataset, which might be, for example, that same value of 250. Adding a clamp is quite simple. I will add a formula, and I will say if my tag is higher than 250, I will clamp it to 250. Otherwise, I'm going to use the tag itself. And the tag I'm going to use is, of course, the flow tag. I'm going to give this a name, Tutorial Thursday FIC1005.pv underscore clamped. And when I add this tag, I will overlay them on the same scale. You notice that indeed this tag has an upper limit now artificially induced of 250. If I would now go and compare what the average value is, you notice that I get the same result of around 185 compared to if I were just not using a filter over 2000 for the original tag. So I'm within 1% accuracy here of the tag of interest. Advantage here is that this gives me more flexibility. I can now add other filters, other conditions that otherwise with the previous filter would have been a little bit complex. But the downside is, of course, that I lose a little bit of accuracy. So if a 1% is okay, I can live with this. Otherwise, I would probably have to fine tune the results a little bit more, or I could combine this tag with an additional filter to get rid of the noise. The third way is a little bit more complex. I'm going to add another formula, but it's going to be a bit more of a gliding window. So what I'll do in this case is I'll add another formula, and I will actually say if A higher than 250, use B, otherwise use A. And what will A and B be in this case? It's going to be twice FIC 1005, but in case B, I'm going to shift this tag by 1 minute. So that applies for those very short bursts, those very short spikes. I will use the previous value, and I will call this TT FIC 1005.pv underscore shifted. So basically, I'm using the last good point as my reference point. Otherwise, I will use the tag itself if it's a clean value. Now, if I overlay these tags, I'll see immediately that indeed they are nicely overlapping. I don't even see the blue tag anymore because it perfectly matches the pink tag. But let me just show you what that tag looks like. There we go. Perfectly clean tag. So let me show and compare these two tags. Let's give them each their own scale. You notice that the blue tag is actually perfectly rid of the spikes of the pink tag. That's what I was looking for. If I were now going in, I want to compare the averages. I'll notice that I get that 184.88 in this case. So very, very close to the value I had before with the filters. I think this shows you the impact of pre-processing. In any case, I will get a value around 185, but the steps that I took, the pre-processing algorithm I used, will define the last number, the last significant digits. This is something you'll never have a way around. This is always going to be the case. Even if you were to use the raw data from the historian, remember that those values are actually already pre-processed in a way, because an algorithm is used when storing the data. There we have it. Quick and simple Tutorial Thursday for this week. We showed you 3 ways in which you can pre-process your data to get rid of spikes. Now remember, the key takeaway lesson here is that depending on the pre-processing steps you take, the end result might be slightly different. This is in no way, shape, or form an issue. And remember that even the raw data in your historian has already gone through some pre-processing steps to store the data in an economic manner. Thanks for watching. If you have any comments or suggestions, leave them in the comment section below. And if not, see you in a couple of weeks.